Good afternoon, everyone, and welcome to the first session of our four-part series in the new academic year, Urology Speaks. My name is Mohammed Alaf, and I serve as the Executive Vice Chair of the Department of Urology here at Johns Hopkins. In a few moments, I will formally introduce our speakers for today's webinar, but let me first thank Doctors Patrick Walsh and Christian Pavlovich for their willingness to speak on such a meaningful topic. We are delighted to see so many of you have tuned in to listen and participate, especially as September is Prostate Cancer Awareness Month. Prostate cancer is the second most common type of cancer affecting men, and in recent years, we've come to learn more about how genetics and family history play a role in a patient's likelihood of developing the disease. Much of what we have learned has come out of the Brady, our department. The advances that you will hear about today are made possible through the trusting partnerships between physicians, patients, and families who all share the commitment to our mission. Our dedication to patient-centered care inspires us to ask challenging questions and pursue research that will create positive outcomes for this generation and for many generations to come. In 1915, one very special patient, Mr. Diamond Jim Brady, enabled the establishment of our institute through a transformative gift made in grateful acknowledgement of the treatment he received then by Dr. Hugh Hampton Young, a trailblazing surgeon and the forefather of the field of modern urology. Mr. Brady's gift launched our institute over a century ago, but we are able to advance his vision today thanks to generous individuals who continue to support and champion our work. Today's webinar is being recorded and will be made available if you would like to pass the recording along to friends or family who might have an interest in this topic. After our formal presentation, we look forward to answering your questions. Please use the Q&A button at the bottom of your Zoom screen to submit a question at any time during or after the presentations. We will try our best to answer as many as we can. And now, I proudly introduce you to our speakers. The first speaker likely does not need any introduction. It is Dr. Patrick Walsh, University Distinguished Service Professor of Urology. Dr. Walsh is recognized internationally as a pioneer in the diagnosis and treatment of prostate cancer. He is best known for a monumental contribution to patient care and urologic surgery, the development of the nerve-sparing radical prostatectomy, a technique that protects a man's potency and continence. Dr. Walsh received his undergraduate and medical training at the Case Western Reserve University, residency and fellowship training at the Children's Hospital Medical Center in Boston and at the University of California, Los Angeles. He joined the faculty at Johns Hopkins in 1974 as director of the Brady Urological Institute, a position he held for 30 years. His scholarly contributions include 15 years on the editorial board of the New England Journal of Medicine, 25 years as editor-in-chief of Campbell's Walsh textbook of urology, and he has co-authored best-selling books, The Prostate, A Guide for Men and Women Who Love Them, and Dr. Patrick Walsh's Guide to Surviving Prostate Cancer. I must also add that Dr. Walsh has been a personal and professional mentor to me during my entire career, and for that, I'm most thankful. Dr. Christian Pavlovich holds the Bernard L. Schwartz Distinguished Professorship in Urologic Oncology at the Brady Urological Institute. Nationally known as a talented minimally invasive cancer surgeon, he also serves as the director of the Brady's Prostate Cancer Active Surveillance Program. He's also the fellowship director of our Urologic Oncology Fellowship. He's a graduate of Harvard University and the University of California, San Francisco Medical School. And he came to Johns Hopkins after completing residency at New York Hospital Weill Cornell Medical Center and a Urologic Oncology Fellowship at the National Cancer Institute. He is a NIH, National Institutes of Health and Department of Defense funded investigator whose research has made incredible strides to identify early detection methods for prostate and kidney cancer. At this time, I'm going to turn the screen over to Drs. Walsh and Pavlovich for their presentations.
Thank you, Mo, and welcome to all of you. Thank you for spending the afternoon with us learning about hereditary prostate cancer. I'm going to dedicate my talk to our patients, who I've always considered our partners in discovery. In this talk, I think you will learn how important they have been to our mission of discovery. Let's begin with a review of some basic science concepts. What does DNA do? DNA is a long molecule that contains our unique genetic code. Like a recipe book, it holds the instructions for making all of the proteins in our bodies. Chromosomes are composed of DNA sequences called genes, and they are the genetic blueprint which directs the synthesis of proteins. What causes cancer? Damage to DNA. DNA damage can be caused by smoking, ultraviolet light, oxidative damage, inflammation, aging, a number of things. And changing just one letter in the DNA code can cause cancer. I'm going to speak more about that in a little while. Now, there are three major genes that can be affected. Tumor suppressor genes. They are normally present in all cells, and when mutated, it's like taking the foot off the brake in your car. Oncogenes. These turn on cell growth, and if mutated, are like stepping on the accelerator in a car. And DNA repair genes. These are like a spell checker that corrects mistakes when cells divide. If mutated, widespread mutations occur. So what is the difference between genetic and hereditary? Because all cancers arise from damage to DNA, all cancers can be considered to have a genetic basis. If the DNA damage occurs within an organ, like the breast, the prostate, or lung, these are called somatic changes and affect just that organ. However, if the DNA damage is in the ovary or the testis, affecting the egg or the sperm, these are called germline changes. This is hereditary cancer. It affects every cell in the body, has the potential to cause cancer in multiple organs, and is inherited by future family members. This is what we're going to discuss today, hereditary prostate cancer. The genes I'm going to speak about are rare, about 5% of all prostate cancer patients. So why is such a rare form, hereditary prostate cancer, important? Well, first, it offers the opportunity to identify men and their family members who are at high risk for developing prostate cancer. And as you will learn, for some genetic mutations, other cancers as well, so they can begin PSA testing at an earlier age. By identifying genetic pathways, also, this may lead to prostate cancer. This may inform new approaches to treatment and ultimately, ideally, prevention of the disease. Discovery of hereditary prostate cancer. In the late 1980s, I saw a 49-year-old man with prostate cancer who asked me an important question that I could not answer. Is prostate cancer hereditary? When I asked why he wanted to know, he said, because my father, my father's three brothers, and my grandfather all died from prostate cancer. Well, at that time, virtually every woman knew that if her mother or sister had breast cancer, her risk was twofold increased. But I had no idea about the risk for men with a family history of prostate cancer, and I had two maternal uncles who died from it. Here was an important opportunity for discovery. When I mentioned this idea to others, they sort of blew me away and said, how can it be hereditary if every man eventually develops it? So no one seemed to recognize this as an important problem, and no one seemed to be working on it. So I went to the literature And there were 3 papers, all dealing with the Utah Mormon genealogical registry. Prostate cancer deaths were increased 3-fold for relatives with prostate cancer. If your brother's affected, there's a 2-fold increased risk of diagnosis. And if your brother is less than 62 years old, there's a 4-fold increased risk. So at that time, actually, when I first read them, I wondered if there was a rare founder mutation in Utah Mormons from inbreeding, or if these findings could be confirmed in another population of men. So we carried out this study, and here is where our patients became so important. So to confirm what's going on in Utah, I invited 741 consecutive patients I had operated on between 1982 and 89, and 683 spouses or female companions. They were asked to fill out a 20-page questionnaire and a 30-minute telephone conversation. And we had full information on 95% of these patients. They were our partners and are our partners in discovery. So now we carried out 3 studies. The first one was to confirm the aggregation. And yes, if they had 1 first-degree relative, their risk was 2.2-fold increased. If they had 2 or more, up to 4.9. And soon, these findings were confirmed by other investigators. Next, let's talk about family history. Family history does not distinguish the influence of inherited genetic factors from a shared environment. The most precise way to identify a genetic basis is through a segregation analysis. And here again, we use the data from the patients I just told you about. So what's a segregation analysis? So here we see a large pedigree. You'll see a few more. Men are squares, women are circles. A line through it means the person is deceased. If the box is filled in, the man had prostate cancer. Well, in a segregation analysis, you try to determine if the pattern of transmission between one generation and the next is consistent with Mendelian inheritance. We evaluated this in 106 multiplex families and published it in the Proceedings of the National Academy of Sciences in 1992. This segregation established for the first time the genetic basis of prostate cancer. And the best model predicted that it would be autosomal dominant inheritance. That means you could inherit it from your father or your mother. That the gene we were looking for was going to be rare, 3 out of 1,000. But if you inherited the gene, it had high penetrance. It meant that if you inherited it, you developed the disease. And it was characterized by families with early age at diagnosis and multiple affected family members. Next, using this same database, we were able to define what hereditary prostate cancer was so that we and other investigators around the world would have a standard definition they could use in studying the disease. 3 or more first-degree relatives, father, son, or brother, or 3 generations, grandfather, father, son, or 2 first-degree relatives like brothers if they are both less than 55 years old at diagnosis. So, prostate cancer runs in my family, doctor. What's my risk of developing the disease? Well, like I just said, you can inherit prostate cancer from either your father or mother. So you need to know about your father, his father, and their brothers, and your mother's father and her brothers, and their ages at diagnosis. And let's take an example here. Let's say that your father had prostate cancer at age 70, and we set the relative risk at 1. It's higher than that, of course, but let's set it there. But if your father was diagnosed at age 50, and say your brother has it, the risk is 7-fold increased. So the next challenge was, how do you find the genes? And the way you do that is called linkage analysis. And this is what we do. You take multiplex families like I just showed you, And you then test them. There are 23 chromosomes, and we have markers spaced in different spaces on each chromosome. And what we're looking for is one area on a chromosome that is shared by all affected members, linkage of inheritance to a site. You then enlarge that area, and you then look for candidate genes there. Well, when we did that, we were very successful within 2 years to find the first hereditary prostate cancer gene on chromosome 1. We and others around the world found other ones, but sadly, few loci were consistently identified by multiple investigators, and none fulfilled the criteria for a high penetrance mutation like the breast cancer genes. Now, let me tell you why that was very frustrating. The study I'm going to show next estimates the heritability of different cancers, and it's based upon the study of twins. Identical twins have the same DNA. So if cancer were 100% genetic, if one identical twin developed it, the other would also. However, if it has no genetic basis, the likelihood of identical twins both developing it is the same as non-identical twins. And with that analysis, you can estimate heritability. So the heritability of prostate cancer is the highest for any common cancer. It's 57%. And you can see here's ovary, kidney, breast, and colon. And this is what was frustrating. For the most heritable disease, we could find no mutations, yet there were established mutations for all of these other cancers. So, despite strong evidence for a heritable component, identifications of the genes was elusive. So, where is the missing heritability? Well, as opposed to breast cancer, where there are only 2 major genes, we reasoned that maybe there are many pathways, like many roads to Rome. So, could there be multiple rare variants that contribute a large effect? Well, let me show you the problem that we are facing. To identify these mutations is like trying to find one misspelled word in 20 sets of the Encyclopedia Britannica. That's right, 400 volumes. But fortunately, a technique came along called next generation sequencing, high throughput sequencing, which made it now possible to accomplish this task. So it took us 20 years, but using that in 2012, excuse me, in the New England Journal of Medicine, working with investigators from the University of Michigan, we identified the first prostate cancer specific gene, HOXB13. So here you're looking at 4 different families. Again, the black boxes are affected men, and 18 of the 18 men with prostate cancer, where we had available DNA, shared this same mutation. So let me summarize what we know about it. This is the first validated prostate cancer susceptibility gene, which occurs to be what's called a founder mutation, which originated in Nordic countries. 60% of carriers develop prostate cancer by age 80, very similar to the breast cancer genes. And this gene is prostate specific, and in mice plays a critical role in the development and maintenance of normal prostate function. It's very rare, associated with significant increases in risk, particularly in men with early age at onset and a positive family history. Well, the next breakthrough came 4 years later. In 2016, authors from the Stand Up to Cancer Research Group looked at men with castration-resistant disease, men who were dying from prostate cancer. And they looked at their germline for DNA. And surprisingly, almost shockingly, they demonstrated that 6% of men with castration-resistant prostate cancer had germline mutations in BRCA2. And when they coupled this with other genes involved in DNA repair, like ATM and the mismatch repair genes, the total number of castration-resistant patients with inherited mutations in their germline rose to over 12%. That same year, we, along with our colleagues at North Shore, looked at men who died from prostate cancer prior to age 65. And again, we found 10 to 12% carried germline mutations in the breast cancer genes and ATM. So here is HOXB13. HOXB13 is prostate specific. No other. These other genes were all identified for other cancers. Look, here's BRCA2, prostate cancer, female and male breast cancer, ovarian cancer, cancer of the pancreas, CHEK2, very similar, ATM, the same, including leukemia, lymphoma, skin, liver, stomach, and brain. So the question is, maybe we were looking in the wrong place. Our studies have always concentrated on men with multiple affected living family members. But based on the recent discovery that patients who have lethal aggressive disease, and here is the imponderable, without a strong family history. I mean, if all these men had a strong family history, we would have found this many years ago. But for some reason or other, most of these men do not have a strong family history, but can carry DNA repair mutations in their germline. So maybe we were looking at the wrong patients, and it's possible that we will uncover many previously unknown important pathways by studying families with advanced lethal disease. Well, this delay turned out to be helpful because it permitted us to develop one of the largest collections of hereditary prostate cancer families in the world, more than 3,000 families and 8,000 DNA samples. I want to pause here to talk about Bill Isaacs. Bill is the William Thomas Gerard, Mario Anthony Duhan, and Jennifer and John Chalsty Professor of Urology. Bill has dedicated his skill, intellect, and energy for the last 3 decades to uncover the genetic pathogenesis of prostate cancer. And this talk and these discoveries are a tribute to his brilliance and perseverance. The perfect gift. In February 2018, when I turned 80, the Brady Institute's Director of Development inquired, if a patient asks what you would like for your birthday, what would you say? Well, now that it was possible to sequence every exon, so an exon is a group of genes that, it's a gene, a group of DNA sequences that spell out the recipe for a protein. So now it was possible to sequence every exon in a patient's genome for a reasonable price. So I said, I'd like enough money to perform whole exome sequencing on our hereditary prostate cancers to uncover the missing heritability of prostate cancer. That message was shared with our patients, and our patients responded with an amazing $3 million in gifts to establish and support the Patrick C. Walsh Hereditary Prostate Cancer Program. So where are we today? Discovery and characterization of the genes responsible for hereditary prostate cancer. Well, as a result of the immense generosity of our patients and friends, we have uncovered a trove of genetic variants that hold great promise for our understanding of hereditary prostate cancer. We know we are going in the right direction now because so far we have found 50 to 60 variants that had not previously been identified as cancer-causing genes. Now we must functionally characterize them and define their mode of action. Well, Dr. Isaacs has put together an ambitious plan and recruited an outstanding group of investigators to carry it out. This ambitious plan also has an ambitious budget of $4 million. The gift that continues to give. In the fall of 2020, one of my long-term generous patients, Ross Myers, heard about our effort, and he and his wife wanted to help. During our conversation, he became animated and expressed a concern that many of you feel. If this will help prevent my sons and grandsons from walking in my shoes, I will help. Originally, he pledged $1 million, but upon further reflection, offered, I will give you $2 million if you can match it. What an inspirational gesture. Thanks to his gift and the generosity of others, we have been able to move forward. So far, we have raised $1.58 million toward the match, and we are working hard to raise the rest. With these resources and our ambitious plan, we are optimistic that someday we will solve the mystery of the missing heritability. So now Dr. Pavlovich is going to speak.
Thank you, Dr. Walsh. I trust you all can hear me, and I appreciate the opportunity to add to what you have said, even if in a small way. The natural sort of follow-up would be to ask, as a patient or as a patient's family member, should I or my loved one get tested? And if so, how? Dr. Walsh has described the most important discoveries related to the hereditary aspects of prostate cancer and how many of these discoveries are being made at Johns Hopkins and have been made at Johns Hopkins. This is painstaking work, primarily because of the genes and parts of the genomes involved in the development, progression, and spread of prostate cancer. These are disparate, and they are small and fragmented and numerous. Recent breakthroughs in sequencing technologies, however, have not only sped up the science, but also allowed for genetic testing to be available to almost all men. Let's start with a simple question. Why get genetic testing? And again, I'm talking about germline genetic testing, meaning testing of your blood or saliva, something not prostate related that implies the genes in your body that you inherited from your parents. This is because genetic testing can inform treatment considerations if you have aggressive or recurrent prostate cancer. It's also because genetic testing can inform a man's need for screening and biopsy to look for prostate cancer. And another reason would be because genetic testing may identify a genetic mutation that can be passed on to one's offspring. Again, at a 50% chance per offspring. Okay, but then who should get tested? Well, annually, testing recommendations are made by a panel of experts at the National Comprehensive Cancer Network, also known as the NCCN. And these recommendations change over time as new data accumulate, new genes are found, and new predisposing factors are accounted for. So in 2021, the NCCN recommended the following genetic testing for men with prostate cancer. And seeing the list of participants today, I can add also, since I see some of my patients here, men who have had prostate cancer. And the answer would be to test men who have prostate cancer that's metastatic, i.e. has spread to lymph nodes or distant sites like bones. Genetic testing is recommended for men that have cancer that is high risk or very high risk, which means a very high PSA or a high Gleason score. It's also being recommended for men whose cancers were or are intermediate risk and have intraductal histology. And there's a little picture here of that, which shows the cancer growing within a duct of the prostate, which of course is an exocrine gland and is full of ducts. And also for men who have a personal history of other cancers. In other words, they have had pancreatic and or colorectal and or gastric and or melanoma, upper tract urothelial, glioblastoma, a brain tumor, biliary cancer, small intestinal cancer, or male breast cancer. So this is the testing recommendations currently for men with a history of or who have prostate cancer. Now, the NCCN is also recommending testing for men with prostate cancer who have a family history of prostate. And this family history would be one or more family members, first-degree relatives with metastatic, regional, or high-risk prostate cancer, one or more first-degree relatives with prostate cancer at a young age, two or more first, second, or third-degree relatives with prostate cancer, which was at least Gleason 7, or breast cancer, or 3 or more relatives, this is first, second, or third degree, with Lynch syndrome associated cancers. And these include cancers like colorectal cancer, endometrial cancer, upper tract urothelial cancer, et cetera. The Lynch syndrome is one where a family has inherited predispositions for cancer based on microsatellite instability genes. And prostate cancer is something that can be increased in these families as well. Family history also of greater than or 1 first, second, or third degree relative with breast or colorectal cancer at a young age, less than or equal to 50, and or colorectal, male breast, ovarian, pancreatic, or metastatic, regional, or high risk, very high risk prostate cancer at any age. And also men who have a family history of a known familial cancer risk mutation, like some of the genes Dr. Walsh discussed, ATM, CHEK2, or the breast cancer genes BRCA1 or 2. And again, this is relatively complex and they're updated annually, so this can be found on the NCCN website where they have a physician's or a patient's friendly link. Finally, they recommend genetic testing for men with prostate cancer who are of Ashkenazi Jewish ancestry, and that's primarily because of the high chance of carrying the breast cancer predisposition genes in this patients with this kind of history. Now, for men at risk, genetic testing can also be considered in men. Again, in men primarily who are increased risk for prostate cancer, still not recommending genetic testing for all men. So the following men should consider testing and early PSA screening, say at age 40, in consultation with their physician. And that would be men with a family history of prostate cancer in a first or second degree relative with either metastatic prostate cancer or ovarian or pancreatic or male breast or metastatic breast or colorectal cancer at young ages. Or a family history of prostate cancer in 2 or more first or second degree relatives with the breast, colon, endometrial, or pancreatic cancer at any age. And in men in a family with a known or suspected cancer predisposition gene, like the breast cancer genes that we were talking about. Well, this seems reasonable, but how does one get tested? And the good news and bad news is that many testing companies would certainly like your business, and there has been a real proliferation of these companies. And thankfully, many do take insurance. Certainly Medicare, but not always private insurers have extended this coverage. And the tests do not typically cost more than about $250. This is a list of some of the companies. Color and color.com would be the website. Invitae, Ambry Genetics, Myriad Genetics, and now not a company, but a clinical trial called PROMISE, which I want to spend a few moments talking about because it is something that is come in part out of Johns Hopkins. Then there's GoPath Laboratories in Chicago, which also is working in collaboration with us on some research projects. Now, the PROMISE registry, which stands for a Prostate Cancer Registry of Outcomes and Germline Mutations for Improved Survival and Treatment Effectiveness, provides free virtual counseling, germline testing, and confidential reporting. Target enrollment is 5,000 men with prostate cancer of any grade or stage, and enrollment just started, so there are numerous availabilities. The concept is to study mutation frequency and effects in prostate cancer and better inform patients with mutations and with what they call variants of unknown significance about best treatment options in their cases. This would be truly personalized medicine, telling men what to do and how to go forward if they've been found to have a mutation or an alteration that does not quite rise to the term of being called a mutation, but is definitely an aberration compared to the typical genetic sequence of a gene that is of an unknown significance. And those are the variants I mentioned. The PROMISE team is being led by Channing Paller, one of our medical oncologists here at Johns Hopkins, and Heather Cheng at the University of Washington. And they are partnered with a variety of different organizations, as you see here. And their tests will be run through the color.com platform, as well as Color is not just going to run its standard prostate cancer panel, but they'll be doing an extended research panel. And all of these results will be offered to the patients who may or may not choose to share them with their physicians but of course we recommend that they do so. This is the website, and if you have a prostate cancer diagnosis of any kind, you do not have to fulfill some of the NCCN criteria. You can go to this website, sign up, and they will send you a genetic testing kit for free, usually saliva-based. So final concept, as Dr. Walsh pointed out, only some 6 to 12% of men with prostate cancer carry a mutation in a known cancer predisposition gene. This percentage is, of course, sure to increase with additional study and discovery, but this could take some time. And testing even the higher risk men has only yielded this 6 to 12% chance of finding something. However, men with prostate cancer and men at risk for prostate cancer may also harbor heritable predispositions for cancer at areas we call SNPs, or single nucleotide polymorphisms. These SNPs are scattered throughout the genome, but when analyzed together through genome-wide association studies, they can be quantitated into a genetic risk score. So while few men actually have mutations that we know that predispose to prostate cancer, all men have a genetic risk score. And a high GRS can predispose to prostate cancer and to multiple prostate cancer areas or foci within the prostate. The GoPath labs in Illinois perform GRS testing for men at risk for prostate cancer and for men with prostate cancer. And they perform the GRS and the mutation tests we talked about for about $250. The prostatecancerpromise.org will only look at mutations, whereas this laboratory, for the additional fee, will look at these GRS areas. Some urologists are currently using the GRS to help inform decision-making for biopsy, and we here are using it for research purposes currently and in our cohort of men with prostate cancer on active surveillance. So I wanted to again thank you all for the opportunity to speak and to add to Dr. Walsh's excellent outlay and lecture, and turn it back over to Dr. Aloff to get to our Q&A. Thank you.
Thank you both for a wonderful presentations. Questions are starting to pepper in, and I'm going to take one that I think is fairly teed up for me. You mentioned there is a matching campaign right now to support this research. If I wanted to make a gift, how can I be sure my gift qualifies for the match? And I would say, great question, much appreciated. We certainly could not pursue this work with such vigor and creativity without the financial support and partnership with supporters. And I would say that you can make this tax-deductible donation to the Brady Urological Institute and ask for it to be earmarked to the Patrick C. Walsh Hereditary Prostate Cancer Program, and that will enable the dollar-to-dollar matching through the generous gift of Mr. and Mrs. Myers. And gifts can be made by mailing in a check, online, credit card, stock, or wire transfer. And the details can be found on our website under the section Ways to Give, or you can contact our development team at 410-955-8434. So thank you so much for that question. Another question that came through says, if I have hereditary prostate cancer, but I don't have sons, I have daughters, what is the risk to my daughters? Dr. Walsh, maybe you can comment on that.
Yes, well, it all depends if you carry a mutation. I don't think that and I could be wrong about this, I do not think that if you have just a father with prostate cancer, there's any good evidence that you'll have an increase in breast cancer. There is minor influence that if a woman has breast cancer, the mother, her son may be at increased risk. But the real risk comes from these BRCA1, BRCA2, ATM. That is, so if you have hereditary prostate cancer and it's from one of those genes, yes, women are at increased risk. And sadly, as opposed to men, the BRCA2 gene, for example, men typically do not develop prostate cancer until they're in their 60s. The problem with the breast cancer genes is you can develop breast cancer when you're in their 20s and 30s. So what I emphasize to patients who have daughters is we have to do testing with your daughters when they're young. So if indeed they carry this, they will be under the right kind of breast care.
Thank you, Dr. Walsh. And I think, to sort of look into that issue a little bit more, there's family history alone. Just knowing that a family member first degree has prostate cancer confers an added risk to having prostate cancer. And then there are these genetic mutations, the monogenic, the BRCAs, the CHEK2s, the ATM, that also add a risk. And both are not the same. And then there's the SNPs that Dr. Pavlovich talked about. And so I would say hereditary prostate cancer encompasses, different groups. And certainly the BRCA patients would require additional workup at an early age for daughters. So thank you for that.
So to make it, maybe I could simplify my answer. And that is, if I see a patient with a strong family history of prostate cancer who has daughters, I say, yes, we should have genetic testing to be sure that you don't carry any of the breast cancer genes.
Some great questions coming in. If I have Gleason 6 low volume, but I'm positive for a genetic mutation, they don't say what mutation that is, but let's say it's BRCA2, and my father died in his 60s from prostate cancer, should I still be on active surveillance? I'm 57 years of age. Dr. Pavlovich.
This is very important question, and we don't have enough data to truly say for sure. I think active surveillance, as Dr. Walsh has always taught me, is really a compact between the patient and the surgeon, that the surgeon will not let this cancer get out of hand, and the patient will comply with the strict surveillance criteria that the surgeon proposes. When you have someone with a mutation, Mo, and there are only about 2% of men in our 1,000-man cohort that actually have these kinds of mutations. So they're rare, and they're more common in men with aggressive disease. Should these men be watched? They need to be watched extremely closely. And I think the big concern is that their Gleason 6 either is adjacent to a more aggressive cancer that was missed, and for that we have MRI and serial biopsies, or this is a cancer that has a higher chance to becoming more aggressive over time because of the genetic germline predisposition. I think it's a bad idea to surveil a man like this, and I'll say that out in this forum, but it is hard to come out with a very strict statement like that based on evidence, because there are a host of men who are being still watched with these mutations who have just not progressed yet. So I would intensify surveillance, or just say it's a bad idea outright at this point.
I think that's very fair. I think a controversial area, and I would say proceed with caution if you're going to do active surveillance, and watch it very, very closely. I was diagnosed with prostate cancer at age 47 and a very high PSA, greater than 100, and Gleason 9. I understand the recommendation is for my son to begin PSA testing at age 40. Is there a downside to begin PSA testing sooner? And what other tests exist that can help my son detect their cancer earlier?
Well, PSA testing is the gold standard, and prostate cancer in the 30s is very rare. I've treated about 20 men with it out of my 4,000 some patients. So we say 40, and what we say is if the PSA is greater than 0.6, they may have something going on, and they need to be screened at closer intervals. Right now, PSA testing is the only certain thing. I have not heard of anyone doing MRIs on young men to look for something. The problem is every time you do a test that's untested and you find something, it can lead to unnecessary investigation. I'm sure at some point or other we will hear about MRIs in patients like this, but certainly at age 40, that son should have a PSA.
Thank you. Another question. I had prostate cancer. My father had prostate cancer, both in our early 60s. My daughter developed breast cancer. Our genetics are negative for BRCA1 and 2. Any thoughts? Is this something that we see in practice, and this is an unknown mutation perhaps, or a change genetically? Dr. Pavlovich, do you want to tackle that one?
I know that when we investigated kidney cancers back in my fellowship years ago, we struggled with patients who had a genetic predisposition and actually had a gene, and then patients in families that did not inherit that gene, that mutation that caused the kidney cancer, and yet who on rare occasion would develop a kidney cancer on their own. And so it was difficult to distinguish a hereditary cause from a environmental or sporadic cause. And as Dr. Walsh pointed out, even with the hereditary nature of prostate cancer, the hereditary factors other than these mutations are going to confer as much as, what was it, Dr. Walsh, 57%, 60%. There's still an environmental, somatic, time-based rate of mutation in cancer development. So I think one has to entertain the fact that this could be, in a way, bad luck or environment, because breast cancer is rather common, prostate cancer is common. And we also have to admit that despite years of searching, there are many predispositions and no doubt genes that confer predispositions, especially when they're multiple, that we haven't found yet. But I would encourage them to stay abreast of the latest panels that are being done. And if they got genetically tested 5 years ago, I can assure you the panels now are broader and they should get genetically tested again.
And they should see a genetic counselor. I mean, their PAL-B now is another gene that causes breast cancer. I don't know what its risk is for prostate cancer, but this is the perfect setting to see a genetic counselor or maybe a breast center where the daughter could be followed carefully, so all of the latest information would come out.
A question came in: why are African American men more likely to develop prostate cancer? Are any of these genetic changes relevant in African American men?
So this is something that Bill Isaacs has been very interested in, that we have tried to work on. And let me clarify the statistics for African Americans. African American men are 60% more likely to be diagnosed with prostate cancer. 60%. And there's a 200% increase in their likelihood to die from prostate cancer. So death from prostate cancer in African Americans, sadly, has a lot to do with socioeconomic issues. And that is education to know to be tested, the availability of testing, insurance. And it's been shown that African American men who are diagnosed oftentimes do not get the most aggressive treatment. So that's one issue that has to be tackled. And there's going to be a new fund that we are going to have looking at all of those issues. Maybe when I'm finished talking, you can mention that, Mo, because you're very involved with that fund. But we have to come back to the fact that they are more likely to develop it. And we are looking for genetic markers that help us understand it. So there is no question that they are more likely to get it. We don't know yet what that is. People talked about diet, eating food with preservatives in it, a variety of things. We don't know, but I believe there must be some genetic issue also. What can you tell us about the new fund that's just been opened?
Yeah, thank you, Dr. Walsh. And this is a question that's near and dear to my heart and our hearts here in Baltimore. We recently launched a program called the Schafeld Prostate Cancer in Black Men program. And it's due to the generosity of the Schafeld family. The vision and aim of the program is to have a community-facing and a community-serving pillar where we go out into the community and spread health literacy related to prostate cancer, prevention, screening, and care. The second pillar is a scientific pillar to discover the underpinnings of why it's more prevalent and why it's more aggressive in Black men, and to study some of the disparities as you said, in access to the latest and greatest in treatments. And then the third is an educational effort to bring people into the field who want to study this issue and to diversify the field of urology. So stay tuned on that, and maybe we'll have a Urology Speaks on this issue alone, which I think would be an interesting topic. Dr. Walsh, you mentioned something about diet and what have you, and a question that came up is, what can be done to prevent prostate cancer? What do we know? What do we know about that? People talk about vitamin E, selenium, lycopene. What's the latest and greatest on that topic?
So I thought I might be asked this. So I actually am going to read from my book for lay people, Dr. Patrick Walsh's Guide to Surviving Prostate Cancer, just so I don't leave something out. If you must drink alcohol, do not have more than 2 drinks. And let me pause for a second. The number one cause for aggressive prostate cancer today is obesity. So fighting obesity is going to be a center component of this. If you can't give up red meat, then eat less, and try hard to minimize or eliminate processed meats like salted, cured, smoked, or preserved meats such as bacon, sausage, ham, hot dogs, and deli and lunch meat. Don't get all your protein from animals, plenty of vegetables. Beware of charred foods. The char on chicken or meat has a carcinogen in it called PHIP. If you inject that into rats, female rats, they get breast cancer. In male rats, they get prostate cancer. Do not take finasteride, selenium, vitamin E, or any of the myriad pills advertised in magazines or on the internet. Anything that has pros in the name of it, stay away from it. If you are on a statin or an NSAID for other reasons, you should keep taking them, but don't start one just for prostate cancer prevention. So the number one thing is to maintain a healthy weight through diet and exercise.
I think a good dictum is a heart healthy diet is a prostate healthy diet,
Yes.
which is wonderful for overall health.
But there are no pills to prevent it. So don't take any pill to prevent it. Actually,
if I could add to that, no supplements. Please don't try to take more vitamin E or more vitamin D or more selenium. That's been shown to be, if anything, dangerous.
That's right. Increases. Vitamin E increases the risk for prostate cancer. And men who take more than one supplement or vitamin a day have an increased risk for developing advanced disease and dying from it.
We know that PSA screening has had multiple people saying multiple things about when to get screened and when to get your first PSA rectal examination. What is your thoughts on the first PSA for an African-American man with a family history of prostate cancer? Or any man with a family history of prostate cancer?
Age 40.
Yeah. I think that's...
I don't know if are you going to say when should men stop testing? Because I think that is maybe for this audience, it's a very important one.
Let's take that one on, Dr. Walsh.
And because the guidelines say, you should stop at age 70. The fact is that half of men who die from prostate cancer are diagnosed after the age of 75. So you're a healthy person, age 75, you say, oh, gee, I don't have to take it. If your PSA, if you're 75 and your PSA is greater than 3, your risk for prostate cancer is not over. You fall into the category of patients who are at increased risk for developing the disease and dying from it. So, and that's for healthy men. So for men that aren't very healthy, you should stop when your lifespan is less than 10 years. If you're a healthy man, and at age 75, your PSA is 3 or greater, you should continue PSA testing.
Just fantastic questions here. Any correlation between BPH and the likelihood of developing prostate cancer, Dr. Pavlovich?
Well, BPH brings men into the urology office. So men with BPH will be more likely to have their PSA checked, have a prostate rectal exam, and ultimately be diagnosed. But I don't know that BPH itself is a true predisposition for prostate cancer. I always discuss this as being two separate entities. And therefore, I would say no. We also know that men with benign prostatic enlargement and larger glands, when the cancer is found, it's more often contained, confined, and lower grade. Again, these men have large, they see urologists, and we do a variety of tests on them to try to help their quality of life, and sometimes almost serendipitously find the cancer. Dr. Walsh, any other thoughts on that front?
No, I think that's good. There was a recent paper suggesting that maybe it will be it's possible that BPH may reduce the frequency of it, but just as you point out, it can also lead to diagnosis.
And there's a slew of these associative studies that make the mainstream kind of headlines: vasectomy correlation, with prostate cancer diagnosis, and it's because people who go and get a vasectomy have a urologist who's checking on them, and they get a higher incidence potentially because they're discovering it. A question came through, Dr. Pavlovich, since you're active surveillance director, on Gleason 6 cancer. And somebody said, isn't it basically inevitable that you're going to get Gleason 6 prostate cancer? And is it really cancer?
Yeah, I mean, that is definitely a fascinating question. And you'd have to go into things like the actual definition of cancer. We always think of cancer as a disease of uncontrolled growth and proliferation and spread that will eventually get to the rest of your body and consume you. The great crab, the cancer. Gleason 6 cancers, confirmed by expert pathologists, do not seem to have that potential. Does that mean they're not cancers? And I would say no. And I think the predominant answer is that they still are felt to be cancer. It's just cancer that has not quite acquired enough mutations to continue to proliferate, but not enough mutations to leave and spread by lymphatics or the bloodstream. You and I and Dr. Walsh, we've all seen patients with very large, bulky Gleason 6 cancers. Very rare, to zero patients with Gleason 6 cancers that have metastasized. And when that has been seen, there's often a higher grade element found within the cancer. So my thought is that these cancers clearly have a slightly higher mutation rate than the benign prostate. They're more predisposed to becoming an aggressive cancer with metastatic potential. And I prefer to keep the cancer nomenclature for a Gleason 6 tumor because it just doesn't behave in a completely benign fashion when observed over time. And we have recent data to show that some of these do, in fact, seem to become Gleason 7 cancers or worse in repeat biopsies from the same areas. I think it's a mistake to call them benign, because the opposite of cancer is benign, and then we're going to lose a large tranche of men to, let it go, and then 75 is the new 55, and these men all of a sudden are alive and well and living to ripe old ages, and then getting progressive cancer.
Perhaps we have time for one more question. I think this is a good question. Why are you raising money for this research? Doesn't the government fund it? Dr. Walsh.
Yes. Well, the point is the success in getting government funding is to not ask them to fund a pipe dream. So we firmly believe that there are a number of undiagnosed HOXB13-like genes out there. And so the way you're successful at funding is you get pilot funds to explore the issue. Right now we have 50 or 60 very exciting potential cancer-causing genes. Then to put some data together to show that those genes actually are cancer-causing. And that's when you step in for the big program projects to get multiple investigators and multiple institutions to work on it. But if we just went to them with a pipe dream and say, we think there's probably a lot more cancer there, they would want proof before the government spent money testing it. And that's why we're so fortunate to have patients who are our partners in discovery. They not only help do discovery like you saw, but they help make it possible.
We certainly are, and we stand on the shoulders of the thousands of men and women who've come through before us, and really could not be where we are without this partnership in discovery. And I want to thank you both, Doctors Walsh and Pavlovich, for joining us this afternoon and laying out your investigations and findings with such clarity and promise, and for answering so many excellent questions and recording of this and questions. This event is recorded and will be available on our website in the coming days. And a big thank you to all of our guests who joined the webinar and for your continued support of the Brady and Johns Hopkins Medicine. Without you, our work would not be as impactful or meaningful. And certainly, if you have any questions about how you can support these efforts, please reach out to the email, address, and phone number that will be listed on the screen and that we will share with you. And then finally, if you enjoyed today's session, please consider joining us for many of our future sessions in this series. Our next one, I think, is going to be particularly interesting, is scheduled for Thursday, December 2nd. And really, it's going to be a multidisciplinary team of faculty who will conduct a mock tumor board to illustrate how we here at Johns Hopkins work together from different fields to make complex, patient-centered care decisions. Thank you again for spending time with us today, and I'm sorry if we did not get to your questions. But I thoroughly enjoyed this. I thought it was a treat to have both Dr. Walsh and Dr. Pavlovich, and I wish you all a wonderful fall season, and hopefully everyone stays safe. Thank you so much.